Hello, my name is Steven Morales, and I'll be talking about the career of electrical engineering, its career subfields, and its real-world applications. Okay, what is electrical engineering? Electrical engineering is a major branch of engineering that dates all the way back to the 19th century. Some people that have contributed to this field are James Maxwell and Nikola Tesla. This field is about designing and testing electrical equipment and also combining it with scientific and mathematical principles to be able to solve world problems. It's known as a very broad and diverse field because of the different ways electricity can be used with technology. So how to become one? To become an electrical engineer, you need a bachelor's degree at the minimum, and it has to be from a school accredited by the ABET program. Up-and-coming engineers also need to pass a Fundamentals of Engineering exam to become licensed as engineers. Salary and job growth. With about 190,000 in number, electrical engineers are expected to grow at a rate of 5%, and that doesn't include the electronics portion of it. This means that about 9,000 jobs will open up from 2018 to 2028. Engineers are also known to make very high salaries. A median salary for an electrical engineer is $80,000 to $90,000. The maximum is around $150,000. Career-wise, electrical engineering is actually extremely broad, like I said before, and the subdisciplines that it contains can be very different from each other, or they can overlap. And here I'm only going to be talking about two of them because there's way too many to talk about. And if I do talk about all of them, it will take too much time. So yeah. Power engineering. Power engineering is the oldest subfield in electrical engineering. This field generally focuses on the generation, transmission, and distribution of high electrical power to the public. This means that engineers that specialize in this field have to work on large-scale projects. These projects include the power grid, solar panels, and wind turbines. Electrical systems and equipment are designed to be able to utilize more power, like a transformer, for example. And depending on what project it is, the power station will use whatever it's given to generate electricity. So we have the wind turbine, uses wind to generate electricity. Solar panels, which uses the sun. Communications engineering. Communications engineering is mainly about transferring and manipulating signals. Engineers in this sector can work in a variety of places, which include space stations, satellites, and telecommunications. In more specific terms, communications engineers design electronics that are able to transmit signals, and they also have to take into account the weather, the building obstructions, and other signals, because all those three things could obstruct the signal and not allow it to be able to transfer from point A to point B. So problems that electrical engineers face. One of the main issues an electrical engineer faces is the rapid development of technology itself. Technology is constantly reinventing itself, becoming more faster and in a short amount of time. And engineers need to stay on track in order to maintain control over it. Another problem is the counterfeit components in the electronic supply chain. These cheap products that counterfeiters use can affect both businesses and engineers in negative ways by taking their consumers and their money. And here you have bootleg PS3 and iPhone. Okay, so pros and solutions. So some solutions that they come up with is to invent tracking systems to track the counterfeit components, to be able to detect them, expose them, and throw them away. And for the innovative problem, engineers are starting a culture of preparation so that any new technology can be noticed as early as possible. And they're also keeping track of past technological trends that have happened. So why would anyone want to become an electrical engineer? Well, no career is made specifically for everyone, but electrical engineering provides many benefits for both the individual and the society. One of our newly added basic needs is electricity, and it is easily visible when you look at the world around you. Electricity is able to be used in our homes and businesses because of power. All of our technologies need electronics to be able to function. I wouldn't be able to deliver this presentation to you if it wasn't for telecommunications, and our computers and operating systems would be non-existent without computer engineering. Engineering itself is just a service to others, and it helps propel society into the future. It's very, very important to our day-to-day life, but we just don't know it.